Hello everyone. So the question is for the circle x square plus y square is equals to r square. We need to find the value of r, which is radius, for which the area enclosed by the tangents drawn from the point 6, 8, which is point P, to the circle in the chord of contact and the chord of the contact is maximum. So we have to find that value of r. Basically, we have to find the maximum value of r for the given situation. As per the given diagram, I'm drawing the as per the given situation, I'm drawing the diagram. So this is the diagram as per the given equation. This is center O, this is A, this is B, this is P. AP and BP are the tangents. AB is the chord of contact. And we have drawn this OA is equals to R, OB is equals to R. And I have assumed this angle at theta. Now proceeding forward, I can see here that it is that OP, this OP, what would be the value? So if I am applying Pythagoras theorem in triangle OAP, this angle is 90 degree and this angle is also 90 degree. So therefore I can write OP square is equals to under the root of this is 6, this is 8, then it would be 6 square plus 8 square. Therefore OP comes out to be under the root of 100, which comes out to be 10 units. So this OP is equals to 10 units. Now proceeding forward, I can say that this PA, what would be the value of PA? So if this is 100, then what would be the value of PA, again using Pythagoras theorem? So PA square would be equal to OP square minus OA square. Using this, I can find PA is equals to under the root of what is OP? This is 100. OP is 10, so square of 10 is 100, 100 minus r square. So this is the value of PA. Now proceeding forward. This is a function of r. So I am writing down f of r. Function of r. Now what would be the area of triangle PAB? This PAB. That would be half of base. What is base? Base is this PA. So half of PA into what would be the height if this is 90 degree? Then in triangle PAB, what would be the height? This is BAB. So AB is nothing, but this is PB sine of this twice of angle. So therefore area is half of PA into PB sine to theta. I'm substituting the values. So this is half into what is the value of PA. So this is now PA and PB is both is equals to under root of 100 minus r square. So this PA and PB, this both are under root of 100 minus r square. So what would the value of PA and PB? The product would be 100 minus r square. The under root will be cancelled into sine 2 theta. I can write it as 2 sine theta cos theta. Now this 2 cancel with this, and what is the value of the area? So this area would be equals to 100 minus r square into sine theta cos theta. Now proceeding forward, if I have to find the maximum value, then I'll have to use P dash F dash R is equals to 0. So 100 minus R square into sine theta cos theta is equals to 0. I'll have to use. Let's okay, I'll have to differentiate this equation. Now proceeding forward, what I get, so differentiating it, what I get, I'll be getting under the root of 100 minus r square into, there'll be quadratic equation inside, that is minus 3r square plus 100 minus r square, that is equals to 0. Now these both has to be 0. From first I can get r is equals to plus minus 10, and from here I can get r is equals to plus minus 5. We can see that the radius cannot be greater than this. It cannot be greater than 6 or 8. So therefore this is the correct answer. Then what is the maximum value of the radius? That is 5. I hope this is clear. Thank you.
Hello everyone. Question says that a swimmer S is in the sea at a distance d kilometer from the closest point A on a straight shore. The house of the swimmer is on the shore at a distance L kilometer from the point A. He can swim at a speed of u kilometer per hour and walk at a speed of v kilometer per hour, where v is greater than u. So we need to find at what point on the shore should he land so that he reaches his house in the shortest possible time. So we have to find the point on the shore for which the time is minimum. Now let us one by one draw the figure for the given question. So they are saying that a point S is at a closest distance from A. So we know that the distance between 2 points is closest when their distance is a straight line, is in a straight line. So this is a straight line, and let that this point is A and this point is S, where the swimmer is in the sea, and this is the point at the shore. Now we know that his house is at a distance L kilometer from the point A. So let us join this also. Let's say this is a distance that is L kilometer, and his house is L kilometer away from A. So this distance is L kilometer, and mark this point, his house, as, let's say, this is point H for the house. Now he is saying that he is swimming at a speed of u kilometer per hour and walking at a speed of v kilometer per hour. So we have swimming speed, let's say it is, we have u kilometer per hour, and the speed of walking speed that we have is v kilometer per hour. Now at what point we have to find on the shore. So let us mark the point on the shore B. Let us call it the point B, where he should reach from the point S to, so that he will reach his house at the point H in the shortest time. So let us join the point B and S. This is the point S and the point B. Now we have joined S and B. Now we can also say here that this distance from A to B, let us say this distance is x kilometer. Then it is clear that the remaining distance that we will be having will be L minus x kilometer. This is the distance L minus x kilometers. Now this is the figure that we are having from the question. So we have to find the minimum time for the swimmer S to reach the point H. Capital T be the minimum time in which S will reach H. So from figure we can see that in order to reach from S to H, he will travel the distance SB first in the sea. For this he will travel with a speed of u kilometer per hour, and from B to H he will travel with the speed of v kilometer per hour, because BH is on the shore. So we have to find the time t, which will be the sum of the two time. The time that he will take to cover SB distance and the time that he will take to cover the BH distance. So let us consider the two times that we have. So let us consider this T, and we know this is TSB plus TBH. So we will find this. So this is by the formula that we know, time is distance upon speed. So from here we can write down distance we have is SB, and the speed in the swim in the sea that we have is u kilometer per hour. So this is u, and the distance is on the shore bh, and the speed will be of the walking speed, that is v kilometer per hour. This is our minimum time t. Now we will put the values of sb and bh. Now if we see in the triangle ABS. We know since AS is the minimum distance of the swimmer to the point A, because it is given that it is the closest point on the shore, and we know our closest distance is always a always perpendicular to the line at which the other point is lying. So that means the line AS is perpendicular to AB, and the distance AS that we have given in the question is d kilometer. So this distance that we have is d kilometer. Now in this triangle ABS, we can apply Pythagoras theorem. We have AS d kilometer and AB x kilometer, so that we can find BS. So by Pythagoras theorem in triangle ABS, we will have BS is equals to under root d square plus x square. So we can substitute this value of BS, or we can say SB here. So this will be T is equals to BS that we have is under root d square plus x square divided by u, and BH that we have in the figure, this is the distance L minus x. So this is L minus x divided by v. So this is the minimum time that the swimmer will take to reach the point H. Now we need to confirm that this time is minimum or not. So we will differentiate the time function which is dependent on the variable x, because all other variables are u, d and v are constants. So only variable at the time is depending is x. So we will differentiate the function t with respect to x. So this will give d dt by dx is equals to, now the derivation, so 1 by u as it is, and the derivation of under root d square plus x square will be 1 upon under root d square plus x square into 2, and by chain rule derivation of x square will be 2 times x. Now this is 1 by u times this, and this 2 and 2 will cancel. Now for the second term, the derivation of 1 by v will be as it is. It is a constant, and derivation of L will be 0, and this will be minus 1. So the final dt by dx function that we have is x divided by under root d square plus x square into u minus 1 by v. Now to find the minimum point of x, we have to put dt by dx equals to 0. So let us take it equals to 0. So what will it give? This will be x divided by u under root d square plus x square minus 1 by v will come to the right hand side, and this will be this. Let us square both the sides. On squaring both the sides, this will give x square in the numerator divided by u square, and this will be d square plus x square. Under root will cancel, and this will be 1 by v square. Now we will find the value of x from here. So this will be, let's take the reciprocal of this. So this is u square d square plus x square divided by x square, and this is equals to 1 by v square. But this will also get reciprocal, and this will be v square. So from here we can see that u square, breaking the numerator, this will be u square d square divided by x square, and plus x square and x square will give divided by 1, this will give 1, and is equals to v square. So let us take this here, and this will be v square by u square, and from here what we will get x is equals to ud divided by under root v square minus u square. Now this point x is the point of minima or maxima, we can't determine here. So for that, to confirm, we have to differentiate the function dt by dx again. So the function that we have is this. So let us differentiate. The derivation of 1 by v will be 0 because it is a constant with respect to x, and the derivation we are left with x upon under root d square plus x square. So let us differentiate dt by dx with respect to x. So this will be d square t divided by dx square, and this will be 1 by u, and the derivation of d square x square under root d square plus x square, and this will be whole square. We are using product rule, which says that u by v, the derivation of a function u by v, this will be v square, second function square in the denominator, and first function derivative second function as it is minus second function derivative into first function as it is. So we are using this. So here d square plus x square, and this will be under root d square plus x square, and the derivation of x is 1 minus derivation of this under root d square plus x square will be 2x divided by 2 into under root d square plus x square, and the first function x as it is. So this is we have. So this is d square t divided by dx square. Now this 2 and 2 will cancel, and what we will have is, by taking LCM, this will be d square plus x square minus x square, and this is x into x square, and by taking LCM, this will be d square plus x square raised to the power 3 by 2. So this is finally 1 by u d square divided by d square plus x square raised to the power 3 by 2. Now we can see here that since u is a speed, d is also a distance, and it is also squaring, and we are adding two positive terms. So that means d square t divided by dx square overall is always greater than 0 for any value of x. So for the value of x that we have ud by under root v square minus u square, this will also be greater than 0. So this implies that t is minimum at the point x that we have ud divided by v square minus u square. So in the question that we have to find the point, the distance of the point B from A. So this distance will be the x distance that we have got, ud divided by under root v square minus u square is the required answer. Thank you.
So today's question is, a vertical line passing through the point h, 0 intersects the ellipse x square upon 4 plus y square upon 3 equals to 1 at the points P and Q. Let the tangents to the ellipse at P and Q meet at R. If delta H is the area of triangle PQR and delta 1 is equal to maximum of delta H, where H varies from half to 1, and delta 2 is equal to minimum of delta H, where H varies from half to 1. Then we have to find the value of 8 upon root 5 into delta 1 minus 8 into delta 2. Now here the vertical line that passes through the point h, 0 is equal to h, x equals to h. Now it intercepts this ellipse at the points P and Q. So this is the line x equals to h. Let the tangents at these points meet at the point R, and let this point be T. So from here, if we solve the ellipse x square upon 4 plus y square upon 3 equals to 1 with the line x equals to h, then we get y is equal to plus minus root 3 by 2 into under root of 4 minus h square. Now we know that PQ is a chord of contact with respect to the point R. So if we take the point R to be x1, 0, then we can write the equation of PQ as x into x1 divided by 4 equals to 1. That is x equals to 4 upon x1. But we know that the equation of PQ is equal to x equals to h. So from both these equations we get 4 upon x1 equals to h. Therefore, the value of x1 will be equal to 4 upon h. Now, the area of the triangle PQR will be equal to half into PQ into RT. So, this is equal to half of twice root 3 upon 2 into under root of 4 minus h square into x1 minus h. So using the value of x1, we get this as equal to root 3 by 2 into under root of 4 minus h square into 4 minus h square divided by h. So finally we get delta h as equal to root 3 upon 2h into 4 minus h square to the power 3 by 2. Now if we differentiate it, we get delta dash h equals to minus root 3 into 4 plus 2 h square divided by 2 h square into under root of 4 minus h square. Now this is always less than 0. Therefore, we can say that delta h is decreasing. Therefore, we get delta 1, that is delta h max at h equals to half, and it will have the value 45 root 5 upon 8, and we'll get delta 2, that is delta h minimum at h equals to 1, and it will have the value 9 upon 2. Now we need the value of the expression 8 upon root 5 into delta 1 minus 8 into delta 2. So this is equal to 45 minus 36, which is equal to 9. So 9 is a required answer. Thank you.
Question is to find the maximum value of the expression 1 upon sin square theta plus 3 times of sin theta cos theta plus 5 times of cos square theta. ओके सो इस एक्सप्रेशन की हमें मैक्सिमम वैल्यू फाइंड आउट करनी है. तो देखिए ये जो डिनोमिनेटर में ट्रिग्नोमेट्रिक एक्सप्रेशन है इसको मैं सपोज कर रहा हूँ इक्वल टू एफ ऑफ थीटा के. तो ये है एफ ऑफ थीटा इज इक्वल टू साइन स्क्वायर थीटा प्लस 3 टाइम्स ऑफ साइन थीटा कॉस थीटा प्लस 5 टाइम्स ऑफ कॉस स्क्वायर थीटा. ठीक, सो इसको लिखेंगे एफ ऑफ थीटा इज इक्वल टू साइन स्क्वायर थीटा. इस 5 कॉस स्क्वायर थीटा को ब्रेक करें तो ये आ जाएगा प्लस कॉस स्क्वायर थीटा एंड ये यहाँ पर 4 कॉस स्क्वायर थीटा. ठीक, इसमें 2 से मल्टीप्लाई 2 से डिवाइड करेंगे सो दिस इज 3 अपॉन 2 टाइम्स ऑफ साइन थीटा इंटू कॉस थीटा. ओके, बाय द ट्रिग्नोमेट्रिक आइडेंटिटी साइन स्क्वायर थीटा प्लस कॉस स्क्वायर थीटा इज 1 प्लस 3 अपॉन 2 टाइम्स ऑफ 2 साइन थीटा कॉस थीटा साइन 2 थीटा प्लस 4 को लिखेंगे 2 इंटू 2 सो 2 कॉस स्क्वायर थीटा होता है हमारे पास 1 प्लस कॉस 2 थीटा के इक्वल. ओके, सो ये हो गया 2 कॉस 2 थीटा प्लस 3 अपॉन 2 टाइम्स ऑफ साइन 2 थीटा प्लस 2 1 2 और 1 3 दैट इज प्लस 3. तो ये एफ ऑफ थीटा की वैल्यू आ गई. ठीक, अब देखिए एक प्रॉपर्टी है दैट ए साइन थीटा प्लस बी कॉस थीटा की जो वैल्यू है वो लाई करती है माइनस टाइम्स ऑफ स्क्वायर रूट ऑफ ए स्क्वायर प्लस बी स्क्वायर एंड इज लेस देन इक्वल टू स्क्वायर रूट ऑफ ए स्क्वायर प्लस बी स्क्वायर. ये इसकी मैक्सिमम मिनिमम वैल्यू है. ठीक, तो अब देखिए हमें ये चाहिए तो हम इसमें क्या करते हैं ए की जगह सब्स्टिट्यूट करेंगे 3 अपॉन 2 और बी की जगह सब्स्टिट्यूट करेंगे 2. ओके, और थीटा क्या है हमारा 2 थीटा के इक्वल है. तो ये हो जाएगा माइनस टाइम्स ऑफ स्क्वायर रूट ऑफ ए स्क्वायर दैट इज 9/4 प्लस बी स्क्वायर दैट इज 2 स्क्वायर इज 4 इज लेस देन इक्वल टू 3 अपॉन 2 टाइम्स ऑफ साइन 2 थीटा प्लस 2 टाइम्स ऑफ कॉस 2 थीटा इज लेस देन इक्वल टू स्क्वायर रूट ऑफ 9 अपॉन 4 प्लस 4. इसे सिंप्लीफाई करें 4 4 जा 16 16 प्लस 9 इज 25 25 का स्क्वायर रूट हो गया 5/2. तो ये आ जाएगा माइनस 5 अपॉन 2 इज लेस देन इक्वल टू 3 अपॉन 2 टाइम्स ऑफ साइन 2 थीटा प्लस 2 टाइम्स ऑफ कॉस 2 थीटा इज लेस देन इक्वल टू 5 अपॉन 2. ठीक, अब हमें यहाँ पे 3 और चाहिए तो 3 ऐड कर देते हैं थ्रू आउट. सो ये हो जाएगा प्लस 3 प्लस 3 प्लस 3. तो ये तो हो गया हमारा एफ ऑफ थीटा इज लेस देन इक्वल टू 3 2 जा 6, 6 plus 5 that is 11 by 2, 3 2 जा 6, 6 minus 5 that is 1, so that is 1 by 2. ओके लेकिन हमें चाहिए क्या, हमें वैल्यू चाहिए 1 अपॉन, क्योंकि हमने सिर्फ डिनोमिनेटर को एफ ऑफ थीटा माना है तो ये टर्म हो जाएगा 1 अपॉन एफ थीटा का। तो हमें इस 1 अपॉन एफ थीटा की मैक्सिमम वैल्यू कंप्यूट करनी है, तो इसका रेसिप्रोकल करें तो 1 अपॉन एफ थीटा इज इक्वल टू क्या होगा यहाँ से, तो 2 अपॉन 11, तो 2 अपॉन 11 हमारा इधर साइड आ जाएगा एंड 1 बाई 2 का रेसिप्रोकल 2 ये इधर आ जाएगा। तो यहाँ से देखें 1 अपॉन एफ थीटा इसकी मैक्सिमम वैल्यू क्या है, तो इसकी मैक्सिमम वैल्यू क्या है, इक्वल टू 2, so therefore this is the answer. So therefore the required maximum value of the given expression is 2.